Hello, I am your Rupa madam. Today I would like you to discuss you about tricks for problems based on Afbau's, Pauli's exclusion principle and Hund's rule. See, first of all, see what is meant by Afbau principle. See, the principle for Afbau is in the ground state of the atoms, orbitals are filled in the order of their increasing energy. See, I will explain this Afbau principle. Afbau's principle. Afbau's principle means Afbau. It is a German word which means building up. Building up means here electrons are building up. We are building means electrons. We are filling electrons in an orbital of an atom. Here it enters the electron into the orbital having lowest energy. Before entering into the rules, I use it to explain about quantum numbers. Quantum numbers. I am not explaining fully the quantum numbers. I am only at a glance I will give some information about the quantum numbers so that you can understand the Afbau principle. What is meant by Afbau principle, how we can explain and how we can do the problems for this. See, here quantum numbers means these numbers which defines the position of electrons. These numbers defines the position of electrons. It defines the position of electrons. Here quantum numbers are of 4 types. You already know that. One is principal quantum number. Principal quantum number, it is denoted by n. Principal quantum number which is denoted by n. And second one is azimuthal quantum number. Azimuthal quantum number which is denoted by L. And third one is magnetic quantum number. Magnetic quantum number which is denoted by M. And fourth one is spin quantum number which is denoted by S. Here I am not explaining fully the quantum numbers. I am only explaining at a glance. I am giving information about quantum numbers. Here n is nothing but number of orbitals or shells. If n is equal to 1, then L is equal to 0. If n is equal to 1, then value of L is 0. How can you say this? Because here L, the value of L is from 0 to, here value of L is 0 to n minus 1. Here L explains the shape of the orbital. Shape of the orbital L is explaining. Here n is nothing but number of orbits or shells. If n is equal to 2, then L is equal to 0. If you substitute 2 here, then 1. 0, 1. If n is equal to 3, then L is equal to 0, 1. If you substitute 3 here, 3 minus 1 is 2. If n is equal to 4, then L is equal to 0, 1, 2, 3. Here in the same way n is equal to 5 up to n is equal to infinity we can write. If L is equal to 0, 1, 2, 3, here L is nothing but it gives the shape of the orbital. L is giving the shape of the orbital. If L is equal to 0, 1, 2, 3, if you take here, if L is equal to 0, the shape is S. If L is equal to 1, the shape is P. If L is equal to 2, then shape is D. If L is equal to 3, the shape is F. Here L is equal to 1 means the shape here nothing but the shape of orbital is P. If L is equal to 1, the shape is P orbital. According to Afbau's, first electron enters into orbital which is having lowest energy. We can write like this. Here L is equal to 0 means we can write it as L is equal to 0 means we can write it as 1. Here it represent 1 and here it represent S. It is not magnetic number and spin quantum number. I am discussing about this only. L and N. Here 1S. And here L is equal to 0 means N is equal to 2 means we can represent 2 here and 2S. 1 is, the shape of 1 is P, 2P. Like this 3S, 3P, 3D, 4S, 4P, 4D, 4F. Here for 0 S, for 1, P, for 2, D, for 3, 4, F. Similarly, n is equal to 4 means we are representing like this. Similarly, 5S, 5P, 5D, 5F, 6S, 6P, 6D, 6F, 7S, 7P, like this. You can fill like this. If you fill like this, then according to Afbau rule, first electron enters into orbital which is having lowest energy. I am explaining like this, having lowest energy. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, like this. If you fill like this, we can explain about the Afbau rule. That means electron enters into the orbital having lowest energy. According to Afbau rule, the increasing energy, that means the order of filling of these electrons, how can you say, means the increasing energy order. If you see according to Afbau rule, Afbau's rule, the order of increasing energy, the order is nothing but here first 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, then 5s. Here how can I say, means 1s first, filling up of 1s orbital, next 2s, next 2p, next 3s, next 3p, next 4s, next 3d, 4p, 5s, like this. If you observe this, you can easily write this increasing energy. How it is explained means, for example, how these orbitals are filling up of electrons in this way only means, for example, here nucleus is present, electrons are revolving around the nucleus. If electron is present here, then the nuclear attraction between the electron and the nucleus is more, so that we can remove the electron easily. If the electron, so that we can remove the electron easily, it is having more energy. So that it is the stable electron. If the electron is here, then it is having more attraction towards the nucleus, hence it is an unstable one. Here if electrons enters into orbital having lowest energy, which is having lowest energy, then it follows n plus rule. Now if we get confusion how the electrons are filling up of orbitals, means it is following n plus L rule. See how this n plus L rule applies. If you observe this n plus L rule, if you get confusion how the electrons are filling based upon this Afbau's rule, can follow n plus L rule. If I am taking the energy order 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p. Write n value here. Here n value is 1. Here 2, 2, 3, 3. Here 3. Here 4. Here 4. Write L value as we now only explained you about the L value. Here 0, 0. Here 1, 0, 1. Here P means 1. Here D means 2. Here S orbital means 0. P means 1. On adding this n plus L, we are getting 1, 2, 3, 3, 4, 5, 4, 5. We are getting these values, n plus L value. Electron enters into orbital where the n plus value is low. That means here lowest energy is. How the electrons are filling means 1s. See, I am filling the electrons 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Here for s only 1 is there. Here 2 electrons are filled easily. Here 2 electrons, here 6, here 2, here 6. As we know this 3d 10, 4p 6. As we know, this is the increasing energy. In this way we can enter the electron. We can learn from magnetic quantum number. As this the filling of electrons, it can be learned from the magnetic quantum number. How it is filled means, here the value is 3 and 3. On comparing these three values, n plus L value, if you observe this 2p and 3s, these are 3 in number. But here n value is 2 for 2p and n value is 3 for 3s. N plus value, if n plus value is same, then we have to observe the n value which is having lowest energy. Here 2p is having lowest energy when compared to 3s. So I written like this. Similarly, here 4 and 4 is there. For 3p and 4s. Here 4 and 4 is there. See here. I wrote like this means here 4 and 4. Here for n value for 3p is 3. For n value 4s is 4. So I wrote like this. Similarly, in the same way 3d and 4p. Like this, the highest energy is here, this one. Next rule is Pauli's exclusion principle. Next rule is Pauli's exclusion principle. We will see what is meant by Pauli's exclusion principle. No two electrons in an atom can have the same set of 4 quantum numbers. No two electrons in an atom can have the same set of 4 quantum numbers. I will explain this rule. See, here for example, if you observe the carbon electronic configuration is 1s2, 2s2, 2p2. I write like this. For 1s, 2 electrons. For 2s, 2 electrons. For 2p, 2 electrons. 1s, 2s, 2p electrons. Instead of filling like this, if you observe, for 2s, 2 electrons are filled in anti-clockwise. If 2s are filled like this, then it is completely wrong. How we can say like this? How we can say means, here if n is equal to 2, here in the first step, here n is equal to 2, here also 2. Then L is equal to, the L value is, for it is s orbital, so the shape of L is 0. It is also s orbital, the shape of L is 0. For m also here 0, the value is 0. Here also the value is 0. For this electron I am saying, for s orbital it is plus half and it is also plus half. For example, if you observe this electron, then n value is here also same 2, L value is 0. M is starts from minus L to plus L, Here s value is minus half. Here 2, here 0, here 0, here minus half. But here for this electron, here it is having 2, 0, 0, it is plus half. So that one is a clockwise direction and another one is anti-clockwise direction. All the 4, but here all the 4 values for the 2 electrons are same. Hence it is stable compound. Here all the 4 values are same, hence it is unstable compound. Both are in same direction. But here all the 4 values are different. One is plus half and another one is minus half. One is clockwise direction and other one is anti-clockwise direction. So that it is a stable compound. Finally, hence we have to fill the electrons, one in clockwise and other one is anti-clockwise direction. this is about Pauli's exclusion principle. Pauli's exclusion principle means no two electrons of an atom in an atom can have the same set of 4 quantum numbers. No two electrons. Here these two electrons, these only 2 electrons in an atom can have the same set of 4 quantum numbers. Here n value same, L value same, M value same, but S value is different. One is plus half and other is minus half. So this is the most stable compound when compared to this one. This is the most stable compound when compared to this one. This is unstable compound. So according to Pauli's exclusion principle, electrons are filled like this only. Third rule. Third rule is Hund's rule. See the Hund's rule. Now, if you observe the Hund's rule of maximum multiplicity, pairing of electrons in the orbitals belonging to the same subshell P, D or F does not take place until each orbital belonging to that subshell has got 1 electron each. That is, it is singly occupied. I am explaining this Hund's rule. See, for example, if you take 2p4 configuration, 2p4 configuration. For example, if you observe Hund's rule, I am explaining the definition. If you observe the Hund's rule, I am taking oxygen. Oxygen is 8. 1s2, 2s2, 2p4. If you observe, these 2 electrons are filled like this. These 2 electrons are filled like this. These 2 electrons are filled like this. 2p4. Here orbitals are singly occupied. Then only starts pairing. We should not pair. Then only starts pairing. We should not pair like this. We should not pair like this. It is completely wrong. Or we should not pair like this also. We should not pair like this. We have to follow this rule only. According to Hund's rule of maximum multiplicity. That means pairing of electrons in the orbitals belonging to the same subshell P, D, F does not take place until each orbital belonging to that subshell has got 1 electron each. Hence it is singly occupied. Based on these rules, I will give some tricks. See. Based on these rules, that means Afbau, Pauli's exclusion principle and Hund's rule. First of all, see, if a configuration is like this, that means 2 spins are in same direction. As I explained you about these rules, according to Pauli's exclusion principle only, no 2 electrons in atom can have the same set of 4 quantum numbers same. If the electrons are like this, that means here m is equal to 0, L is equal to 0, n is equal to 0, S is equal to, but S is equal to plus half and minus half. According to this trick, if the spins are like this plus half and minus half, here 4 quantum numbers are same. But according to Pauli's exclusion principle, we are not having same set of 4 quantum numbers. That means here it is violating Pauli's exclusion principle. If you observe second trick, if configuration is like this, that means here if the electron after filling s orbital only have to fill another orbital, but here first s orbital is filled, then another orbital is filled with 2 electrons. It is completely violating Afbau's rule. Afbau's rule means we already know that in the ground state of the atoms, orbitals are filled in their order of their increasing energies. First, this orbital is filled with 2 electrons and next with 2 electrons are filled like this. But here it is not obeying Afbau's rule. It is violating Afbau's rule. If you observe this configuration, here 2 electrons or 4 electrons are filled in 2 orbitals. It is not obeying Hund's rule. As we know that Hund's rule of maximum multiplicity means pairing of electrons in the orbitals belonging to the same subshell P, D, F does not take place until each orbital belonging to that subshell has got 1 electron each. That is, it is singly occupied. That means here it is not obeying Hund's rule. For example, if these electrons are filled like this, 1, 2, 3, and this electron are filled like this, then it obeys Hund's rule. If it is filling like this, means it is violating Hund's rule. That means if the electrons are filled like this, then it is obeying Hund's rule. If it is filling like this, it is not obeying Hund's rule. That means it is violating Hund's rule. These are some tricks which can carry out problems easily. That means in any competitive exams of chemistry, if you learn these tricks, then we can solve the problem easily. If you like this video, please subscribe.